Our final video will examine how to solve rational equations. Up until this point, all of our work has revolved around rational expressions. Well, I think there's going to be one obvious difference that you're going to recognize between expressions and equations. And I think we all realize that that's going to be an equal sign. So these are going to be equations. Now, I just want to refresh your memories a little bit on equations that involve, these are considered rational expressions as well, but these ones just have numeric denominators. And I'm going to show you the strategy that hopefully you have picked up along the way of your math career that shows you how to solve these types of equations. The way you would do something like this is you look at your denominators, 2, 3, and 4, and you ask yourself, what would be the least common denominator of those three numbers in the denominators? Well, 2, 3, and 4 would all divide evenly into 12. Now, this is what students do wrong. I shouldn't say do wrong. They will do that will eventually get you to the right answer, but it takes more work. Rather than changing them to the common denominator as if you're going to add and subtract them, you're going to multiply both sides of the equal sign by the least common denominator. I want you to think about this. If I have x plus 3 equals 5, well, based on equality, if you multiply the left side by 2, you're allowed to do that if it's an equation, as long as you multiply the right side by the same thing. So if I was to go 2x plus 6 equals 10, this equation and this equation are the same. This is just a multiple of this one. They're both correct. Well, here what we do is we pick a number to do basically what I did up here, right? So I said, let's multiply both sides, in this case, by 2. Well, down here, we just said, if you multiply everything by 12, watch what will happen. Multiply this one by 12. Multiply this one by 12. I just kind of usually put them out here beside them, wherever I can squeeze them in. And now, you don't actually multiply them, because what you're going to do is divide the 2 into the 12. Because this is in the numerator, this is in the denominator. So 12 divided by 2, I'll just cross this out. And I'm really going to get 6 times x. 6x. 3 goes into 12 4 times. Multiply it by the 2. 4 goes into 12 3 times. Multiply it by the 3. Well, all of a sudden, that ugly looking equation with all those fractions in it is this equation, because I've just multiplied everything in the equation by some number that all these denominators would divide evenly into. And now you just solve it like normal. 6x, add 1 to that, or add 8, sorry, to the other side. Divide both sides by 6. Your answer would be 17 over 6. All right, let's look at this one. 4, 3. Now this is a 6, but it's not in the denominator. So the denominator here is a 1. So that doesn't really matter. It's just these two that I'm going to look at and say, well, what would divide evenly into both of those? Well, the same as the last one. Actually, 12 would work. You can use bigger. You could use 24. You could use 48. It's always easier if you pick the smaller one to keep your numbers small, but anything that they'll all divide into will work. So let's multiply by 12. By 12. Now, students will say this one doesn't have a fraction. It doesn't matter. Every term in the equation has to get multiplied by the same constant in order for it to still be equal. Okay, so 4 goes into 12 3 times. That 3 is going to multiply through the whole numerator. So you're going to have 3x take away 12. 3 divides into 12 4 times. That 4 is going to get multiplied by x. So that's plus 4x. And then this is just going to be 1 goes into 12. Well, that's not going to do anything. 12 times 6 is going to be 72. 7x equals, take that over to the other side, you're going to get 84. Divide both sides by 7. And you're going to get 12. 84 divided by 7 is 12. This top line, if you hear me refer to clear the fractions, that's what we're doing. We're getting rid of the fractions. Anytime you have an equation, now you can't do this with expressions, but you can do it with equations, because with an equation, think of equality. As long as you do something to the left side and then you do the exact same thing to the right side, it's still going to be equal. You can multiply both sides. You can add 6 to the left as long as you add 6 to the right, and so on and so forth. That's the principle of equality. So we are going to clear the fractions. Okay, so now let's have a look at a couple more. So this one, same, nothing changes. The only difference is now our denominators are going to be algebraic expressions. So they get more in line with the ones you were adding and subtracting in the prior lessons. So I look at these and say, well, what would be, if I was actually going to get a common denominator for these, what would it be? It would be 2x multiplied by x plus 1. So I'm going to multiply every one of these by the same thing, 2x by x plus 1. Notice I'm not changing the denominators. I'm getting rid of the denominators. Multiply the right side by the same thing. Now watch what happens. This 2x and this 2x cross each other out. So you're left just with 3 times x plus 1. So that's going to give us 3, I'll write it like this, 3 on x plus 1. Here, what's going to happen? The x plus 1 is going to cross out the x plus 1. You're going to be left with 2x multiplied by 2x, which is subtract 4x squared. Now, there's no denominators and nothing crossed out, so all 3 of these are still going to be left there. So you're going to have, I'm going to multiply these first 2 just to, so minus 4x. Right, so when I multiply these, I'm going to get negative 4x out front. And then I still am going to have my x plus 1. So that's just these 2 multiplied together. All right, let's clean this up. Well, here's the good news. Those 2 ugly fractions, gone. We have cleared the fractions, which is always a nice feeling. They're gone. Don't have to worry about them anymore. So now it's a quadratic. Back to unit 1. 3x plus 3, take away 4x squared equals a negative 4x squared. Take away 4x. Nice thing here is, so it's quadratic. We're going to get everything equal, make on one side, make it equal 0. Let's move it. Usually we try and move it so the x squared ends up positive. Even better here, when you go to move these, whether you go this one here or this one here, they're going to wipe each other out. So the x squareds are going to be gone because we're going to have negative 4x squared plus 4x squared. I've got a positive 3x. I'm going to add 4x. I've got plus 3, and that equals 0. Well, these 2, as I said, are gone. So now I've got 7x equals, take the 3 back over there because now it's linear. Divide both sides by 7, and our answer is negative 3 over 7. Okay, let's have a look at this one. So I have an x in the denominator here. I have x take away 1 here, and I have a 4 here. So to get rid of all of those at once, I'm going to have to multiply by 4x and x minus 1. 4x and x minus 1. 4x and x subtract 1. Now let's see what cancels. This x gets rid of this x. This gets rid of this. And this 4 will get rid of this 4. So let's see what we've got. We've got 6 times 4 times this. So I've got 24 onto x minus 1. I've got 9 times 4x, that's 36x. And here I've got x onto, I forgot my equal sign. So it's not a plus, it's an equal sign. I've got equals x multiplied by x minus 1. We've cleared the fractions, they're gone. Now let's clean this mess up. So 24x, take away 24, take away 36x equals x squared, take away x. This is a quadratic. X squared is positive, which means I want to move all of these over here. I don't want to move that because it'll switch to negative. So 0 equals x squared, take away 25x. Oh, wait, no, that's not going to be right. I didn't see that other one. Undo that. So let's try that again. So x squared. Now, right now, I've got a negative 12x. So that means I'm going to add 12x to this, which is going to give me a plus 11x. That's when I group this one, and I move them over here. The negative 24 is going to the other side, 11. It's going to become plus 24. Try and factor. Any two numbers multiply to give 24 and add to give 11? Yes, there are. They would be 8 and 3, x plus 3, x plus 8, giving me two answers. X could be negative 3, or x could be negative 8. So the strategy is clear all fractions first. Skip that one for today. All right, so here's one where these two are nice, already factored linear factors, but this is something that will factor. You should always, always factor first anywhere you can. So before I ever get into anything, I'm going to factor this, and it will be k subtract, I want to get 12, so it's going to be k subtract 6 and k subtract 2. K subtract 6. See, here's what will happen. So if people don't factor, they think they have to multiply by, get this written out, they think they've got to multiply by this, this, and this. Well, little do you know, look at these. These two factors here are the same as these two. So really, to fix this, all I got to do is multiply by k minus 6, k minus 2, k minus 6, k subtract 2, k subtract 6, k subtract 2. Watch what happens to your denominators. This one crosses out this one. This one crosses out this one. This is all gone, leaving us with just a 4 on the left side. This k is going to get multiplied into here, so k multiplied by k, take away 6. You can expand that as you're going if you want to, just showing every little step here so people can see what's going on. This 1 will get multiplied by that. So the original ugly looking equation is now this. This looks better. Let's expand here. We're going to get k squared, subtract 6k, plus k minus 2. K squared is positive, so let's leave it where it is. Combine the middle two. Subtract 4, you're going to get subtract 6. So we are trying to figure out two numbers that when I multiply them, I get negative 6. And when I add them, I get negative 5. Those two numbers would be negative 6 and a plus 1. K would equal 6. K would equal negative 1. Let's do a couple more with some factoring. So let's look at, I would say if you can do these two, we'll call you a professional factoring. I'm not going to get into the bottom one. Just because the time we have, we don't have time to do that. Okay, so let's look at this one. There's some factoring here. You always do your factoring first. Don't start trying to clear fractions if you have not factored. It will turn into a mess, trust me. Multiply to get negative 15, add to give 2. X plus 5, x subtract 3. Plus, difference of squares. X subtract 3, x plus 3 equals 8. Multiply to get 15, add to give 8. X plus 5, x plus 3. So let's look this over. If I was doing this as expressions and adding these up, what would be the least common denominator? Well, I would need an x plus 5. I would need an x minus 3. X minus 3, I already got it. I need an x plus 3. I need an x plus 5. I already got it. I need an x plus 3. I already got it. So I have to multiply each of these terms in the equation by x plus 5 multiplied by x take away 3 multiplied by x plus 3. Multiply this one by the same thing. X plus 5, x subtract 3, x plus 3. Same thing here. X plus 5, x subtract 3, x plus 3. Cross out or divide out the common factors. This and this, this and this, leaving you with just the 3 onto this. That wipes out that. That one wipes out that one, leaving you with 4 multiplied by x plus 5. That one wipes out that one. That one gets rid of that one, just leaving us with 8 multiplied by x minus 3. That ugly rational expression equation has turned into this nice linear equation. 3x plus 9 plus 4x plus 20 equals 8x, subtract 24. Collect the x's on one side, so we're going to get 3x plus 4x, subtract 8x. I'm going to leave the negative 24 where it is and then move these two over. When I get 9 and 20, I got 29. So I'm going to have to take away 29. That leaves me with 3x, 4, 7, so negative x equals a negative 53, which means divide by negative 1, divide by negative 1. X must be positive 53. And there you have it. That's how you solve equations involving rational expressions. Right? You kind of use the buzzword. The buzzword is clear the fractions. And that will make your life so much easier if you learn that process. All right, so that is how we solve rational equations. In your textbook, there's a set of practice problems on page 348. There'll be just a quick little assignment that we'll use to double check and make sure you're okay with how to solve these. I'll just give you a couple to solve. And that will finish the unit on rational expressions. Right? If you have any questions, reach out. Best of luck.